Hello everybody, welcome to the night class. Today we're going to have a quick introduction, our first lesson in trigonometry. So trigonometry is basically the geometry of triangles. That's why you have the tri and then the geometry part. So trigonometry, you just put them together and that's what you got. Triangles, geometry, angles, and since you're talking about angles, we'll eventually get into circles, but when we get to the circles, we'll basically be making the angles into triangles of the circles. So quick little vocab lesson here. When you're talking about an angle, every angle has a vertex, an initial side, and a terminal side. So if I were to draw one, let's see here, here's the vertex, and the initial side is the fixed ray of the angle. So it's the side that doesn't, it's the side that doesn't move. It's gonna stay. And then the terminal side is where the other angle stops. So if it was going there, it stops there. So this would be the terminal side. This is the initial side. And of course that is your vertex right there where the two rays meet. Standard position is an angle with its vertex at the origin and its initial side along the positive x-axis. So what that basically is, if I were to take my angle here and make a XY coordinate plane out of it, okay, I'm gonna make it where the initial side is on the positive x-axis, okay, and that's called standard position. When your initial side, this orange side right here, when it's on the positive x-axis, the angle is said to be in standard position. And you'll probably remember this standard position. You have quadrant 1 at the top right, quadrant 2 on the top left, quadrant 3 on the bottom left, and quadrant 4 on the bottom right. And so those are your four quadrants in your standard coordinate plane. When your angle, again, when the initial side is the positive x-axis, then that angle is said to be in standard position. When it is rotated counterclockwise, a positive angle is formed. So in our case, it went counterclockwise up, okay? You can also think about it as it's going up, so it's going to be a positive angle. If the angle goes down, like so, it is considered to be a negative angle. So it's a negative angle when it rotates clockwise. It is a positive angle when it rotates counterclockwise. The next thing we're going to talk about is what angles are measured in. They are measured in degrees and radians, but for this section, we're just going to worry about degrees. And a degree can be broken down further. It's kind of like, it's kind of like a yard can be broken down into feet, and a foot can be broken down into an inch. And so same thing. So a degree can be broken down into minutes and seconds. So a minute, it takes 60 minutes to make 1 degree. Okay, and again, that's just a unit of how to measure an angle. It takes 60 minutes to make 1 degree, and it takes 60 seconds to make 1 minute. And so for our first example here, it says change 15.735 degrees, minutes, and seconds. So the problem already gives us the degrees. It's 15 degrees, 15 total degrees, whole degrees. And we have .735 left. So you take that .735 that you have left and you multiply it by 60, because again, there's 60 minutes in 1 degree. So we have .735 degrees. We want to figure out how many minutes that is. So if you put that in your calculator, you will get 44.1. So again, you take that whole number. So that means there are 44 whole minutes. And the symbol for a minute is just a little tick mark, kind of like a foot, okay? Then you take what's left there, the decimal part, 0.1, and you multiply it by 60 again, because there's 60 seconds per minute. So we're trying to figure out how many seconds are left over from this minute, and 0.1 times 60 is 6. And so that is how many seconds you have. So 15 degrees, 41 minutes, 6 seconds would be that angle. Example 2, we're doing the same thing. So again, we're going to have 329 whole degrees. Take our decimal, 0.125, multiply that by 60. If you put that in your calculator, you will get 7.5. So that's 7 full minutes. Take the decimal, 0.5 times 60. You get 30. So there are 30 seconds. 329 degrees, 7 minutes, 30 seconds. That's all there is to that. The next 2 examples will be going the other direction. We will be going from degrees, minutes, seconds, and writing it as a decimal, and it says round to 3 decimal places. So same type thing here. We already know the degree, the whole degree part. So it's 39 degrees. Okay, so 39 point. We've got to figure out the decimal part. So what we're going to do, we're going to take our minutes and we're going to divide it by 60, because remember, we're going opposite. Up here we multiplied by 60 to get our minutes. So here they've already given us the minutes, so we're going to divide by 60, and to that we're going to add the seconds divided by 3600. Now we're dividing by 3600 because to get the seconds up here, we actually multiplied by 60 2 times. So 60 times 60. So down here we're actually dividing by 60 2 times, which 60 times 60 is 3600. So basically you just put 5 over 60 plus 34 over 3600 in your calculator, and you get that decimal and round it to the nearest thousandth, because it says 3 decimal places. That would be, let's see here, 0.093. And so we would just add that to the end of our 39. 39 degrees, 39.093 degrees. So example 4, same thing. Don't worry about your degree, just write it as 35. It's not going to change. 35, we're going to divide 12 by 60 plus the seconds divided by 3600. Put that in our calculator. We'll get 0.202. So we put that on the end, 202 degrees. Example 5. We go off of the degrees, minutes, and seconds, and we start talking about rotations. Now, hopefully you know that one rotation equals 360 degrees. Okay? So basically, example 5 says give the angle measures represented by 5.5 rotation clockwise. So it's a very simple problem. We're going to take 5.5 and we're going to multiply it by how many degrees there are in a rotation. However, notice it says clockwise. So remember, back when we started going over our notes, if it goes clockwise direction, it is a negative angle. So we're not going to multiply this by 360, we're going to multiply it by negative 360 degrees. Stick that in your calculator, you get negative 1,980 degrees. All there is to that. Example 6. This time we're going 3.3 rotations, but we're going counterclockwise. So we're going to do the same thing, 3.3 times, this time counterclockwise. Again, refer back to your notes. Counterclockwise direction is a positive angle. So we're going to multiply this one by a positive 360 degrees. Put that in your calculator and you should get 1,188 degrees. All right. Next thing we're going to talk about are coterminal angles. Coterminal angles. Every angle has an unlimited number of coterminal angles. So just to try to explain this a little bit, if I drew an angle over here, and we'll make it, we'll do an easy, we'll try to make it as easy as I can, 45 degrees. Okay, well that's just to there. Our angle, we could keep going if we wanted to. We could keep going all the way around and come back to it. Well, if we did that, we would be going all the way around to here, from 0 degrees to 360 degrees, and then we'd be going 45 more degrees. So a coterminal angle, okay, co-terminal, that means they share a terminal side. Okay, so this side right here that they're sharing, that is your coterminal, that's your terminal angle side for both 45 degrees and for 405 degrees, because if you said 360 plus 45, you would have 405 degrees. So those two angles share the same terminal side. Now, could we go around again if we wanted to? Absolutely. You can keep going around 360 degrees every time and just keep adding 360 degrees every time, and you can get an unlimited number of coterminal angles. There's not just one. So that's what this is talking about up here. It says if alpha is the degree measure of an angle, then all angles measuring alpha plus 360k, where k is an integer, that means it could be a positive or negative whole number, then they are coterminal with alpha. So alpha is just the variable for the angle we're referring to. So we've already done part A here. It says example 7, identify all angles that are coterminal with each angle. Then find one positive angle and one negative angle that are coterminal with the angle. So first off, all. It is impossible to find all of them because, like I said, there are an infinite number of coterminal angles. So when it says all, it wants us to use the equation up there. So in this case, our angle is 45. So we're going to say 45 plus 360k degrees. That takes care of all of them. Then we have to find one positive angle and one negative angle. So basically, for the positive, I'm just going to add 360 one time, 45 plus 360. K is basically being 1 here when I add 360. That's 405 degrees, so there's a positive angle. Negative would be 45 minus 360. And again, all you have to do is add or subtract 360 and you'll get a coterminal angle. So if you subtract 360 from 45, you will get negative, let's see here, it'd be negative 315 degrees. So there's all of them, a positive coterminal angle, a negative coterminal angle. Part B, 225, so all all the coterminal angles would just be 225 degrees plus 360 times K. A positive coterminal angle, again, I'm just going to add 360 once. If you add 360 once, you'll get, let's see here, it'll be 0, oops, that's wrong. It'll be 585 degrees. And for the negative, I'm going to subtract 360. So 225 minus 360, that would be negative 135 degrees. So for 225, all of them would just be 225 plus 360 times K, again, where K is an integer. For a positive coterminal angle, 585, a negative coterminal angle would be negative 135. And understand, those are not the only two answers. There are an infinite number of answers you could have. That's just the first one that we come to. 595. Okay, so for all of them, a little bigger this time, we're going to say 595 plus 360 times K degrees. For a positive, since this one's more than 360, we can actually subtract 360 if we wanted to. Or you can add 360. It does not matter, whichever one you want to do. It's not going to matter because since it's more than 360, you can subtract 360. So let's see here, 595 minus 360. 595 minus 360, that is 235 degrees. As you can see, that's still a positive coterminal angle. A negative coterminal angle, I would have to say 595 minus 360 twice. And if I subtracted it twice, I would get negative 125 degrees. So again, these are not the only positive and only negative coterminal angles. This is just the examples that I'm getting. Part D, all of it, again, 294 plus 360 times K degrees. A positive angle would be 294 plus 360. That's 654 degrees. A negative angle would be 294 minus 360, and that would be negative 66 degrees. So again, those are all just examples of how to find all the coterminal angles. A positive coterminal angle and a negative coterminal angle. All right, our last little example here, we're going to find reference angles. Okay, so here are your reference angles. It says for any reference angle alpha. So again, alpha is just like your variable. Okay, and notice alpha has to be in between 0 and 360. Its reference angle alpha prime is defined by, okay, so A is just the regular, it's just the angle if it's in quadrant 1. You do 180 minus the angle if it's in quadrant 2. You do the angle minus 180 if it's in quadrant 3. And you do 360 minus the angle if it's in quadrant 4. So I'm going to add this example 8. I'm going to add a little bit to our directions here, and we're going to find the reference angle as well. Okay, so we're going to determine a coterminal angle that's between 0 and 360. We're going to state the quadrant that the terminal side lies, and we're going to find the reference angle. So don't forget what your quadrants are. Here is your standard position. You start at 0 degrees, you go up to 90 degrees, 180 degrees, 270 degrees, back to 360 degrees all the way around, and then you start adding again. Okay, so this is quadrant 1, top left. Quadrant 2 is in the top right. Quadrant 1 is the top right. Quadrant 2 is the top left. Quadrant 3 is the top or bottom left, and quadrant 4 is the bottom right. So here we go. First, determine a coterminal angle that is between 0 and 360. So 775. I'm just going to subtract 360 from that. And when I do, I will realize, hey, that's 415. Is 415 between 0 and 360? And hopefully you say no. So we just subtract 360 degrees again. No big deal. And 360 or 415 minus 360 is 55 degrees. So that is your alpha. Okay. That is your coterminal angle. First off, it is in 55 degrees would be between 0 and 90. So it's in quadrant 1. And so the reference angle, or A prime as they said, okay, A prime as they called it, is equal also to 55 degrees. Because remember, if the angle is in quadrant 1, then the reference angle is the angle. Okay, there's nothing to change there. Part B, negative 1,297 degrees. Now, remember, the negative just meant they go clockwise. Okay, that's all that means. So we're going to add 360. And when we add 360, let's see here what we're going to get. Let me get my calculator out. We got negative 1297 plus 360. That's negative 937. That's not in between 0 and 360 yet, so we're going to add 360 again. Plus 360 again. We get negative 577. That still is not between 0 and 360, so we're going to add 360 one more time. Still, we got negative 217, and finally, we add 360 one more time. We get 143 degrees. That is our alpha. That is our angle, our coterminal angle with negative 1,297. Now, 143 is between 90 degrees and 180 degrees. So it's in quadrant 2. And if it's in quadrant 2, then we say 180 minus the angle. So our reference angle, or alpha, like I said, alpha prime, is going to be 180 minus 143 degrees, which is 37 degrees, is our reference angle. So it was in quadrant 2. Our angle was 143 degrees. Our reference angle is 37 degrees. Part C, 595. We are going to subtract 360. So when you subtract 360 from 595, you get 235 degrees. That is between 0 and 360, so that is our coterminal angle. That's between 0 and 360. 235 would be in between 180 and 270 degrees, so that is in quadrant 3. And when it's in quadrant 3, we use the angle minus 180 to get our reference angle. So our reference angle is going to be alpha prime equals 235 minus 180, which is also 55 degrees like we got earlier. So alpha prime is 55 degrees. And last but not least, negative 77. We are going to try to get it between 0 and 360, so we're going to add 360 degrees. That's negative 417. If we add 360 again, because again, we're not in between 0 and 360 yet, that will be negative 57 degrees. And we got to add 360 one more time. And finally, we get 303 degrees. That is our coterminal angle that's between 0 and 360. What quadrant is 303 in? Well, 303 is between 270 and 360, so it's in quadrant 4. And what do we do if it's in quadrant 4? To get the reference angle, we say 360 minus the angle. So 360 minus 303. My reference angle, or alpha prime as they like to say, is 57 degrees. Okay. These reference angles are not that hard if you draw them, okay? So like this would be alpha. You always make them when you draw them. You always make the angle with the x-axis. See how my vertical line goes straight down to the x-axis? If it's in quadrant 2, it's going to be over here, and it's going to be 180 minus the angle. Okay. If it's over in the third quadrant, it's going to be the angle minus 180. And if it's in the fourth quadrant, again, you always make the triangle with the x-axis. So if it's in the fourth quadrant, it's 360 minus the angle. So I always think of it, always kind of making a bow tie, if you want to think of it that way. Okay, that's just to help you out, because you do need to have your reference angle rules here memorized. These are very, very important to you, and you will use them quite often, especially in Greek. All right, hope this lesson helps. Y'all have a great day, and as always, stay above the line.